Oh, yeah, I'm working. Just let me get off this leash. Well, I know that a lot of you came here today because you knew there will be a beer. You won't trick me. Yeah. So, one of those days, I will make you a trick and bring a water, or worse, non-alcoholic beer. That will. No, I'm not a master. I can't even. I can't even think about such a monstrous thing. Okay, I think I have what? 40 minutes? 45 minutes? Half an hour? 2 minutes? Should we just grab a beer and go home? Oh, Martin, yeah. Okay, so to do this session, I was actually inspired by three things. One is a spoon, like regular spoon. The other one is like a blank piece of paper. And the third, well, so four things. The third one is this little piece of code written in assembler. And this little piece of code was extracted from GNU debugger disassembly. So, in order to walk you through my messy thoughts, I have to tell you a story. And the story begins in 1950. So I don't know if this 1 hour will be enough. So bear with me, I will try to do it fast. So imagine the situation. There's year, as I said, around 1950. Do you know MIT, Massachusetts Institute of Technology? Well, a bunch of geeks out there had modeling club. I don't know what it is with geeks and trains and train models, but it's fun. So they had a modeling group, right? They were doing train models. And one day, hello, Marcin. And one day, they got a gift. They got a gift from a phone company. And the gift was old, damaged switchboard. You know, when there was in old times a phone central thing, they were calling in and where do you want to connect to? And they were, switching cables. And you saw this in the movies. You know what I'm talking about, right? So they got a gift. They were making a train models. They were interested in rails, and they got an old switchboard. So put yourself in their shoes. You're dealing with trains. You have a gift, which is a rusty switchboard. What do you do? Who said that? Yes, that's what you do. First of all, you are fucking happy. Because, come on, I got a switchboard. That's awesome. Why? I don't know, but it has cables. It has cables, and we can, I don't know, put those cables somewhere. So they made they made a tool to control trains with just ringing into appropriate number and putting cables in appropriate spaces. So instead of just going to the rails and doing it manually, they built an automated solution based on an old switchboard to manage the trains. And it was very, very important. You know why do I have this spoon? Because I can put it on the spot and see you for a while. So I could have a hat, yeah. So it was a very important moment in the whole IT history. It was a very important moment for all of us, because those people, for the first recorded time, used a phrase hacking. Okay? So they said that they hacked a switchboard to solve a problem of managing trails. And those were the same people who, a few years later, were one of the first programmers hired in IBM, doing, holes in paper to run a program. And those were people who actually didn't want just a program to go. They had a contest to make a program to go as fast as possible and to use as least resources, so as low number of those cards and tapes as possible to solve the same problem. So they were the first hackers, actually. And they are our ancestors. So, all and glory to them. So, why am I talking about this? Because, well, hacking is an important word for all of us. We actually deal with hacking every day, but the word hacking was twisted by a media. To say that hacking is a bad thing. If you say hacker, you think about a dude who is breaking 256-bit code in 5 seconds by typing really fast on the keyboard, right? And they are thieves and so on. It's actually not true. There's a seat in here. Those people invented a word, hacker. And we are hacking each and every day, actually. So the original meaning of word hacker is to use something that was designed for other purpose to solve a problem in non-standard way. Can you imagine one thing of hacking a spoon right now? Can you do it?
No. I'll try for comedy value.
Who can do it? Yep. Are you willing to go all over the people here? Yeah. Okay. Applause for a hacker. Awesome. I need you. You will be my assistant, because here's your hacking device, and you have very important role, Yep. Great. Okay, so now, no, keep it. Because now, each time I have only a few beers, and there's a lot of you in here, I feel bad not to give it to everyone. So there's now your task to open those beers and give them to people. Just do it. Hug them all. So, applause for the gentleman. Yep. Okay. So he's now hacking a spool. Okay. Great. To solve, I will help you. To solve a problem. And the problem is a closed beer, right? So Yeah. So please be kind and distribute those beers to people. If you could just take a few, and I will help you. Okay. Just someone thirsty. Okay. Yeah. Okay. Yeah. For you. Okay. Help me please with those. Yeah. Okay. Okay. Thank you. So I have two more. Anyone? Anyone here? Okay, yeah.
Keep one. Keep one.
Don't worry. Anyone? So, yeah, great. So, yeah, we use hacking all the time. So, what has happened that we stopped hacking in our professional lives? Because we did. For last 10 years, I'm doing trainings and audits, and I see that the quality of apps, the quality of code is actually dropping. And I was wondering why. And I thought that, well, the thing is that if you give someone a spoon and tell him to open a beer, a regular developer usually will do it, right? But we have some mentality that says that if I give you awesome bottle opener, electronic, flying, controlled over a phone with Bluetooth, because everything with Bluetooth is fucking better, right? Everything that has Bluetooth is better. So if you start using this awesome new bottle opener, a new technology, you suddenly tend to forget about a simple spoon. And we all have the same issue. We tend to forget about simple, basic, base solutions. Instead, we go into modern, new, trendy technologies, and even, well, more, we make fun of people who do it in an old way, right? The dude is still using C++, he is old. So, well, I was trying to figure out what's going on. I was trying to figure out what's going on with me, with my code, and all the code that I can see on a day-to-day basis. And I started to think about my career. So, like 13, 14 years ago, I started as an Oracle developer by accident. I was, well, hungry student. No, I was thirsty student. Living in a dormitory, having no money. So I lied in my CV that I know PL SQL because it looked quite similar to Pascal. And I wrote a few tools in Pascal. And I lied in my CV that I know Java because it looked similar to C++, and I had a book called Thinking in C++. So the guy for whom I was with whom I was interviewing, well, actually, he figured out quite quickly that I know shit. So he suggested a simple solution that, okay, if you are able to learn fast enough, I can provide you all the books necessary, all the materials, and you will work for me for free for the first year. And I will bring you pizza and beer to the dormitory. I was like, fuck, this man is my god. So he gave me books and drinks and food in exchange of code. So that's when I realized what I want to do in my life. And, well, the problem was, Google was not a thing that is right now. There was no Stack Overflow. YouTube just started. Am I old? Oh, you shut up. So, well, I really had to use books. So, but you know how it is. You don't read a book from beginning to the end because it's fucking boring. Anyone ever read a technical book from the beginning to the end? Seriously, who said this? Get out. Okay, no, I never did this. I never did this. You know, I tried, I gave up after 2 pages. So you're looking in index for interesting things. You are rewriting your code. You are doing it first time, it broke, second time, it broke, third time, 100th time. And at one point, it kind of runs. Like, yeah, wow, that's cool. I'm a god. My hello world run after second time. So, well, since I didn't read enough of theory, I didn't have the knowledge. Well, I thought that I don't have the knowledge, but after, 1 million time of rewriting a code, it has occurred that the knowledge came into the fingers somehow. The theory about somatic memory. When you are learning to play a ball and drive a car and everything, you don't think about it, you just do it, right? Did you ever have a situation when you just sat by the keyboard, wrote something, and just didn't think, your fingers are just doing your job? Yeah, that's what it is. This is another level of memory, a somatic memory that also works while learning foreign languages. If you type a lot, if you write a lot, you learn at another level than just remembering. So I thought, yeah, oh, wow, I'm awesome. But if someone asked me a question, I was like, wait a minute. Yeah, I know the answer. So it was kind of funny making a training and standing in front of the people and talking like this. So it took me a while to get this knowledge from my fingers to my brain. And after a while, I noticed that my learning curve is actually dropping. So I'm not learning fast enough. So I thought, well, what has happened? Maybe I'm old. I have already 25 years, so maybe it's time to go retire. I won't learn so fast anymore, right, Martin? So, but then I noticed one thing. Before, I was typing a lot, but the times changed. And I started to use rapid application development tools, Stack Overflow, and I was basically just feeding 2 fingers, Control-C, Control-V, right? I thought that when I read a code and understand it without writing it myself, it will be good enough. Well, it won't. So I made an experiment. I removed everything, all my scripts, all my tools, except for the coloring ones, for the syntax. And I started to learn again, like finding a solution and not copying, pasting it, but writing it myself. The learning curve began to grow. So I thought, wow, we have one awesome capability, one positive thing as an IT people. I love this in us. We are fucking lazy. But this is very specific kind of laziness because we are lazy in a way people from MIT were lazy, right? We are lazy because we don't want to do a job, so then we work to build the tools that will do a job for us. But while you work on those tools, you are not working. You are working to not working. Or you get me? Do you get it? Yeah. So I also had the thing that I spend a lot of time building a tool that will automate my job, like 5 minutes a day, and I spend like a few weeks building the tool. So. But I was not working. I was working not to work. So we have this awesome capability that lets us to create new automation tools. But, well, and this is the laziness, that it's so far advanced in laziness that it's practically, a hard working, but from other way. So this helps, but it is also a problem. Because if someone builds a tool for us, if someone builds a framework for us, we tend to forget about understanding how the thing actually works. So we try to use a framework, we try to use a new awesome thing, like, for example, who saw yesterday's presentation on Graal? Yeah? Awesome. I love it. Really. But I see coming problems in terms of the quality of future code. So, but it's awesome, and I will use it. So we tend to forget how things work. And one time I found this line. You know what it does? It zeros a registry. So it puts RAX is a registry in a CPU. So XOR function, if it takes two the same arguments, it returns 0. Okay, so XOR are one and the same registry will put 0 into this registry. And I thought, wow, what the hell? Couldn't they just put 0? Right? Just, yeah, no. But, at the beginning I was like, why?
It will be 9 bytes. It will be 9 bytes.
Yes. So it's hard to imagine someone working at the lower level right now than assembler people, right? And still, a CPU for them is kind of a framework who makes optimizations on many, many levels. And, well, one argument is that putting 0 into this big registry would be 9 bytes. This would be only 3 bytes. So this is one thing. But the other thing, it has occurred that a CPU has a special optimization for XOR operation. So it can parallel those operations, knowing that this will always be 0. So people who are working on quite amazing but low-level framework like CPU have to know what this framework does at the low level in order to write optimal programs. And I thought to myself, wow, so how many optimization tricks can there be in languages like Java or Python? So we were writing a Python tool to parse binary files. It is for a tool that will do logical replication between the Oracle databases and other databases, some kind of new golden gate. We used Python for parsing binary files. We could use Java, we could use anything, but I don't like Java because, I lied 14 years ago and it stuck with me. I never learned Java. So we used Python, and we didn't get a good performance from Python, but a lot of my code was actually a code that was copied from different solutions. So I had a lot of code there built with best practices and answers from experts on the internet. And I had a lot of performance problems. So the solution was to remove everything, to try to understand how actually Python works, and to build a new code. So each high-level language that is using some kind of virtual machine, like Python or Java, at the beginning is being compiled to a bytecode. So a bytecode can be interpreted by the virtual machine, Java virtual machine, or a Python virtual machine. And understanding how the bytecode is being created and how actually your language is being executed by the virtual machine is a key to write fast programs. So let me, okay, I have a lot of time. I don't have any more slides. Okay, so here we are. This is a simple example of trivial Python code associated with some binary structures. So in here we have a class Duper. You know what Duper means in Polish? The same in your language? No? Okay, so Duper is as, just... If you don't know how to name a variable, you name it Duper. It's normal. I find it in a lot of code in Poland. You just go through a code, you see Duper. Ah, yeah. My man. So I have very simple class that has 1, 2, 3, 4. It will have 4 methods. All those methods will do very simple thing. Basically, I will use binary data structures to store a data. I know that we use a lot of JSON right now, and it's trendy, and well, it's cool and easy to parse, but still, imagine that if you want something to run smooth and fast and store data in a compressed way, you still use a binary way, right? Not a text way, as our good friend Roger McNichol from Oracle said once, there's no such fucking thing as JSON or XML. This is just a fucking string, you know? It's not a data type, it's a byte string. So still you need to use binary structures from time to time. And even in such a high-level language, understanding of how CPU actually works gives you some cool optimizations. As you can see, let's just look at Duper 1 and Duper 2. Duper 1 and Duper 2 are doing the same thing. They are using a structure, a binary structure, data S1 and data S2, sorry, S2, kurwa. Sorry. So data S1 and data S2, and they are using a method called pack to convert Python data types into binary data types. And we have only numeric data types in here, but those two structures are arranged in a different way. So we have 1 byte, we have unsigned byte, so the size of the variable is 1 byte. Unsigned short, the size of the variable is 2 bytes. Unsigned integer, the size of the variable is 4 bytes. And unsigned long, the size of the variable is 8 bytes. And the second structure has the same data types, but in different order. So in theory, there should be no difference, right? So let's run, let's create an object. Let's run Duper 1 and let's check data size. And let's run data 2, okay, and check data size at the end. So the size of the data is a bit different, but both methods are storing the same binary data, actually. So what's actually happening in here? Well, in all CPUs, well, in all Intel-based CPUs, there's a thing called data type self-alignment. So it occurs that when you store something in memory, a variable has to start in a memory, in memory address, which is a multiplication of its size. This is an optimization. So if I get ubyte, so if I put something at the first place here, can I start unsigned short right away? No, right? I have to put something like dummy empty space in here of size 1 byte and start a data in multiplication of its size. And it goes like this even in Python, which is high-level language, but you are using binary types and you are and you have to follow CPU constraints in managing the memory. So this simple trick can save quite a lot of data if you are building things that run in parallel, process the data, and store them either in file or keeps them in memory. Since we were parsing binary files, when we rearranged the data structures, the difference was enormous. It could be gigabytes, depending on the size of transactions that we were trying to parse, just by rearranging the data structures. So, but let's just focus right now on those two methods, because, well, I want to optimize my code. It does a lot of the binary data storing. I was not satisfied with the speed of my code. Okay, parsing a few hundred megabytes of binary files took 174 seconds. And it was only, let me just check it, 3,842 transactions. Not a lot. It was 100 megabytes of output data, so a few hundred megabytes of input data to pass. So I was not satisfied with the speed of my code. So I tried to look for something that will tell me how the Python actually executes a code. Let's check data, the Duper2, Duper2.1, and Duper2.2. Okay? Let's compare the execution times. We will use a simple timeit package for Python. And let's say timeit Duper2, let's say 500. God, it's hot in here. You know, Benjamin Franklin said that in wine is wisdom, in beer is freedom, in water are bacteria. And he was a wise man. Water. Marcin, come on, you know me. Okay, so we can see a visible decreasing of speed of the methods, which do actually the same thing from a logical point of view. So the output of all those three methods is the same, but how they are doing it is very, very different. the fastest one uses quite a few tricks. And how to know what those tricks are? Well, each and every high-level language, as I told you, is compiled to a bytecode at the beginning. And there are interpreters for bytecode, which are something like SQL execution plan for a database. So if you are able to interpret SQL execution plan, you are also able to interpret a bytecode for a sample code and understand what's going on. For Python, there's a module called dis, like disassemble, right? So I can say this duper to 1. Fuck. D dot. Awesome. And let me just close it for a second. Duper. Okay. Import this and this d duper to 2. Great. And here was duper to 1, for example. Awesome. This is our. This is a comparison. Fuck. This is one duper. This is the other one. Okay. So we will try to compare those two bytecodes interpreted by a disassembly in Python. So it has occurred that since Python is a very, very dynamic language, each call to something like self.something has to search in a dictionary of an object for example, a variable. Each call to a method of an object has to issue a dictionary search of a name of a method. And you can understand, right? So each time you are using a dot to go deeper, it has to make a lookup in a dictionary in order to find what are you looking for. And you can see it actually in a bytecode here. This is the beginning of our loop. You can see that this is a for iteration up to byte 78, and from byte just before byte 78 there is a jump absolute to byte 30. Can you see it? Here and here. So this is our loop in here. Okay. So when we let's go there once again. Okay. So when we do, for example, in here, you know what? I will disassemble data to here. Okay. This. Okay, it will be better. Okay. So if we do, for example, in here, data equals self dot data s2 as a structure dot pack and put variable or constants in here, what Python actually does, it uses as load fast, because load fast is getting a variable from my private scope of a method. It's my local scope. That's why it's load fast. And load fast here is loading an address of self, so my object, right? In order to access some kind of variable that was defined in constructor of an object. Then I have load attribute. And load attribute has to search in my private, self public area for a variable called data s2. And when I find data s2, I have to use load method. Again, a dictionary lookup for a method called pack. Then I can load constants on a stack and call method and store fast, so store it in my local variable called data, right? Then, after doing this, I am putting my data structure into a collection, into a list. So again, there is load fast, because this is my local list, but I have to do load method, search for a method in a dictionary, and call a method and pop it onto a stack. And again, I have to look for a data size, count the length, and so on and so on. So this loop in here actually does a lot of dictionary lookups inside the loop. So I thought to myself, well, but again, this code is written according to best practices, right? Object, self-call, and so on, best practices. So I thought to myself, well, fuck best practices, let's make it fast. So Python is kind of dynamic language. So I could use a few tricks. And the tricks were, for example, assign to a variable address to a function that will be called frequently in a loop. So I no longer will have load attribute and search for the dictionary. I will have it only here before the loop. And it's false, I have a big head. So instead of calling pack all the time, I can call my with a load fast my local variable from a local scope. And I will see it in a disassembly. So here I have, this is the beginning of my loop, right? And I have inside my loop, so from here to here, I think I don't have any load attribute. I don't have any load attribute or load method. It's only load fast, load constant, call function. Can you see it? So I removed all unnecessary dictionary lookups by assigning a repeatable things that repeat before the loop. But it's not a good practice. Why not? Because it's harder to read. So if you do this, you have to be sure to write it with appropriate comments that you know what's going on inside. But I think it's kind of worth it, because when I did this, I removed, remember this number? It was, run slow was 174 seconds, right? So, sorry, that's not, I have to start. Yeah, that was fast, but it's not a good, it was not a good fast. Okay, now agent started. So by removing, oh, yeah, that's a good, this is a good number. So by removing all unnecessary calls to methods and making a code a little bit messier, but with a lot of comments to understand what's going on, we could really speed things up. And this is almost a limit, but it's not the limit. We could actually move the performance a little bit farther, but the code would be fucked up, really. So I guess what I'm trying to say is that, well, it's cool that we have, let's go back to the piece of paper, because it's actually, I took a laundry service room from my hotel. It should work. So, in my opinion, all the frameworks, all new technologies, all autonomous bullshit, I mean, all the fucking cloud and so on, all autonomous things, all the frameworks are like a piece of paper, okay? It's awesome that I can have a piece of paper and write on it, make notes. And it's awesome that I don't have to chop off a tree myself. And it's great that I don't have to, produce a cellulose and so on and then make a paper myself. But it's kind of nice to know what is the nature and the structure of a thing that you're working with. Because, well, if you know the nature of it, well, you can, for example, with a piece of paper, try origami, right? So you can watch for long hours origami masters on the YouTube and try to produce, I don't know, a swan, a rose, or something else to, make impression on a girl in a pub. Then you realize that it fucking doesn't work. So you learn to do something useful. Maybe not a swan, maybe not a rose, maybe nothing beautiful, but something that is kinda performing well. Sorry. A soft piece of paper. Wait a minute. Fuck the spoon. There is no spoon. Does anyone have normal piece of paper? This is kind of, the soft one for the... Anyone have a normal one? No? Fine. A laptop? Shit. It doesn't work. It doesn't work. What? Take what? Paper? You have a paper? Awesome. Give me a normal piece of paper because it's kind of...
I'll do your swap.
Fuck you. Oh, thanks. Yeah, that's better. Okay, let me just try it again. So, if you want to say it, yes, you have to put it like this. And again, half. Okay. And during the long edge. And again, the long edge. And, okay, yes, this is a proper piece of paper. Yes. Kinda, it should work now, I think. And now it's all about your wrist. Thank you. And go be hackers. Okay, I can swap now. Where is he? This is a better one, actually.